Hello everyone, welcome back to our Java tutorial series. In today's video, we will understand how Java works internally and how a Java program gets executed. Many beginners can write Java programs, but they don't know what happens behind the scenes when they click the run button. By the end of this video, we will understand how Java code is compiled, what bytecode is, what JVM does, how Java achieves platform independence. So let's begin. So we are going to cover various topics such as introduction to Java program execution, writing Java source code, Java compilation process, what is bytecode, Java compiler, Java virtual machine, we call it as JVM, class loader, bytecode verifier, execution engine, and the JVM architecture, and the platform independence in Java. So what happens when we run a Java program? Java follows a unique process. When we write a Java code, after compiling the code, we get the generated bytecode, and JVM executes those bytecode and converts it into machine code, and operating system understand that machine level code and output is displayed. Java follows the principle write once, run anywhere, that is 4R. So write once, run anywhere. This is achieved with the help of JVM. Since JVM is platform independence, so we are writing once and we can run anywhere in the sense in any platform, and JVM provides us a platform independence, whether it is Windows or Linux, etc. So first step is writing Java source code. Don't worry about the code. We will learn in the later videos how the code is written. We will install the IDE and we will be working on IDE. Since we are in initial stage, to hold a stronger grip in the concepts, what is going on behind the scenes, we are just going through this code. So this is a sample code in which we have the public class hello world. Inside class we have the main method. We call it as entry point. And the third line is the printing line, system.out.println. So this will print the hello world. So for now, just forget about what the code is. Think it like it will print hello world. So file name is hello world.java, which contains these 5 lines of code. So we have written the Java source code, that is step 1. The file contains human readable code, but the computer cannot understand it directly. Therefore, it must be translated into a format that the computer can execute. Second step is compilation. Java provides a compiler called javac. The compiler checks syntax errors, type checking, language rules. If everything is correct, the compiler converts the source code into bytecode. So we have command to compile the .java file, that is source code, and we'll get output as .class file after compilation. So this .class file will contain the bytecode. So role of compiler is to check syntax errors, check type errors, and convert source code to bytecode. So question comes into mind, what is bytecode? So bytecode is an intermediate code generated by the Java compiler. It is neither human readable source code nor machine code. Instead, it is a platform independent instruction set that can run on any system having a JVM. This is the secret behind Java's famous slogan, write once, run anywhere. The same bytecode file can run on Windows, Linux, macOS, or any other platform. So characteristics is platform independent, and it is stored in the .class files, and it is executed by JVM. Then step 3 is JVM loads bytecode. So after bytecode is generated, the JVM takes over. As we know, JVM stands for Java Virtual Machine, and its job is to load bytecode, verify bytecode, and convert bytecode into machine code and execute the program. Every operating system has its own JVM implementation. That's why the same bytecode can run on different platforms without modification. So the JVM loads, verifies bytecode, and executes instruction, and it acts as a bridge between Java program and the operating system. The first component of JVM is the class loader. Its responsibility is to load class files into memory. As we know, we have 5 memory areas: stack memory, heap memory, PC registers, native method stack, and the method area. So this dot class file are loaded into the method area. When we execute a Java program, the class loader finds the required class files, then loads them into memory, makes them available to the JVM. So class loader will load the required class files into the method memory area and makes them available to the JVM. Without class loading, the JVM cannot execute the program. After loading the class files, the bytecode verifier checks whether the bytecode is valid and secure. It verifies proper format, illegal memory access, invalid instructions, or any security violations. This step helps Java maintain security and reliability, and it prevents harmful code execution. As we know, the runtime memory areas. So once verification is complete, JVM creates memory areas for execution. The 5 important runtime memory areas are method area, stores class level information and static variables. Heap area, store objects. Stack area stores method calls and local variables. And other two are PC register and native method stack. The execution engine is responsible for running bytecode instructions. It uses two approaches. Interpreter reads bytecode line by line and executes it. Advantage is quick startup, but disadvantage is slower execution. And another approach is just-in-time compiler. We call it as JIT compiler. It identifies frequently executed code and converts it into machine code. Advantage is faster execution and improved performance. Modern JVMs mainly use both interpreter and JIT compiler together. Java automatically manages memory using garbage collection. When objects are no longer used, the garbage collector removes them from memory. Benefits are it prevents memory leaks, reduces manual memory management, improves application stability. So let's move ahead with complete execution flow. So first we will write the Java source code. Then we will compile the Java source code using Java C compiler, which will generate bytecode that will present inside .class file. Class loader loads the class file into the method memory area. Bytecode verifier checks validity. Runtime memory is allocated. Then execution engine executes bytecode, and garbage collector manages memory, and the program output is displayed. The next question arises, why Java is platform independent? The answer is simple. The Java compiler generates bytecode instead of machine code. Different operating systems have their own JVM. So for example, we have three platforms: Windows JVM, Linux and Mac OS. So for all these platforms, we have their respective JVM. So for Windows, we have Windows JVM. For Linux, we have Linux JVM. For Mac OS, we have Mac JVM. So we have bytecode, which is generated from the .java file. So after compilation, .java file is converted into .class file, which contains bytecode, and that bytecode is converted into machine code with the help of JVM. So Windows JVM will convert the bytecode into machine level code for Windows, and Linux JVM will convert bytecode into the machine code based on Linux, and Mac JVM will convert the bytecode into the machine level code based on Mac OS. That's how we achieve platform independent, and this enables Java's famous principle, write once, run anywhere. So let's summarize what we have learned so far. Java source code is written in .java files. Java C compiles source code into bytecode. Bytecode is stored in .class files. JVM loads and verifies bytecode. Runtime memory areas support execution. Execution engine converts bytecode into machine code. Garbage collector manages memory automatically. And Java follows write once, run anywhere, since Java is platform independent because of JVM. That's all for this video. Thanks for watching. See you in the next video.